Hello everyone. In this tutorial we will learn about method overriding, that is runtime polymorphism, and upcasting of objects. We have seen a brief about the method overriding in our previous tutorial. In this tutorial we will have a detailed look. So see, I have created a class A with three methods. The first one is the method, the second one is method A, and the third one is method A1. Similarly for class B, I have created a single method called void method. So now let's create an object of the B class. Let's call our method. Let's execute the command now. Method of class B is invoked. That means whatever I will do, it will always invoke the method of class B. So this is method overriding. That means if you are having a method with the same name in the parent class and the child class, it will always execute the method of the child class. It doesn't matter how many level you go in the inheritance, it will always execute the method with the same name for the child class. So this is your runtime polymorphism, but as you can see, I have created both the method with the same name, but there were no arguments. So now let's check the another example to see the same thing with the different number of arguments. As you can see in this example, I have created two classes. The first one is the add class and the second one is the add2 class. In this, I have created a method with two different arguments, int a and int b, and then I have printed the summation of those two variables. Similarly, in our next class add2, I have again created the same function with the same name sum2, but have passed different arguments in between that, and have again printed the summation of all the three variables. So let's create the object now. Now let's call the sum function. As you can see, when I pressed S in my keyboard, I have got two options. Both are the sum function but with different variables. So that means runtime polymorphism doesn't exist on the different parameters. Runtime polymorphism always work with the functions with the same type. So this is all about runtime polymorphism. Now our next topic is upcasting of object, that is too related with the runtime polymorphism. As you can see, what we have done over here is we have instantiated the object of class B, that is new B. By this we have instantiated the object of class B, and again we have given the reference of class B, that is we have given the reference of class B over here, that is B. In upcasting, what you can do is you can create the reference of the class A, that is A equal to, and you can create the object of class B. By passing the reference of class A, what you have done is you have told your object that the method which is present in the class A, if it is also present in the class B, then it will execute that method from the class B. If any of the method which is not present in the class A and is present in the class B, it will not be executed. So in a simple way you can say that once you have upcasted an object reference, you can only access the field and methods declared by the base class. If there is same method or variable in the derived class, that is your child class, then it will be overridden. Apart from that, no other method will be called from the derived class. Let's have a look. I have created the object of the child class with the reference of the parent class. Now let's call our method. See, we haven't got any error. Let's execute the command. Method of class B is invoked. Let's create another function over here. See, we have created another function, that is method B in class B. So now let's try to call this method A dot. As you can see, as I tried to write method B, I have not got any of the option for the B. If I will forcefully write the B, it will still give me an error. The error is the method B is undefined for the type A. That means class A doesn't contain any definition or declaration for the method B. But if you would like to call any of the method from the class A, you can still call it from here. So let's execute the command and see the output. Method A is invoked. So this is how you can do the upcasting. So now you might be wondering that why we are using upcasting. It is because if you would like to call the functions from the parent class which are not present in the child class, then you can use the upcasting. And And there is one more important thing about the upcasting. We will discuss that later in our abstract classes. It will be easy for you to understand it over there. So this will be all about the runtime polymorphism and upcasting of an object. In this tutorial, we will learn about hierarchical inheritance. Hierarchical inheritance can be best defined as, suppose of a family in which father is the head of the family and then their kids are the siblings. Similarly, in hierarchical, we have a parent class and there are number of siblings, that is child classes. So let's have a practical look. Let's go to Eclipse. In this example, we will be calculating the area of various shapes, that is rectangle, square, circle, or any of them. So let's first create a class called area. Then we have to create a class called square, class rectangle. We have already a class named area, so we can't use it again. So let's change the name to shape. Now the error has gone. I have just declared the prototype over here, that what kind of function we will be calling. So there can be a function without any arguments, there can be a function with one argument, and there can be a function with two arguments. Now let's inherit the class shape. I think you might know the area of the square. So let's write the void area int side, and in between that let's print out the output. Let's do the same for the rectangle. We have created a function for the rectangle too to calculate the area. Now let's extend the class to the shape class so that it will inherit the property of that class. See, we have successfully created our program now. As you can see, there is a green arrow around line number 18. It says that override object oriented.shape.area. That means the function over here, that is area function in the rectangle class, is overriding the function of the area in the shape class, that is this one. So now let's create the object. As you can see, we have two classes that are extending to the superclass. That means we have two subclasses or two child classes. So we have to create two objects. So as you can see, I have created the object of the child class for the square and another child class, that is rectangle. And I have called the function of that classes with the help of the object. So now let's execute the command. In the console window you can see we have got our desired output, that is area of square is 25. It will execute this method rather than this method because it is overridden. You can see it over here on the 10th line, the green arrow sign. Overrides object oriented.shape.area. So this is how you can do the method overriding, and this is how your hierarchical inheritance will work. There is one more important thing, the same which we have learned in our previous tutorial, that is upcasting of objects. Let's apply the same over here. So now let's just create another method in the rectangle class. We will find the circumference. So let's see, I have created a method called circumference to calculate the circumference of the rectangle. I have given the formula over here in the print statement. Now don't say that you don't know the formula of circumference of the rectangle. So this is it. Now let's try to call that method using the object of the rectangle class. R1 dot circumference, have to give the value. See, we have given the value. Now let's execute the command. We have got our desired output as 18. But this is not a good practice if you have just created the program for the area of any shape. So what you will do is, you will pass the reference. The same thing which I have told you in the upcasting of objects. Let's apply it again so that you will remember it for sure. Because we will be using the upcasting of objects when I will be teaching you about the abstract classes and interfaces. So it's a better practice if you will remember it right now. Then it will be easy for you to remember it then. Let's pass the reference of the shape class. We will create the object of the rectangle class, but we will pass the reference of the shape class. So by doing this, what will happen here is that it will take the reference of the shape class. That means it will make a copy of the shape class and then it will compare it with the rectangle class. If our JVM will find any method that is same as that of the shape class, it will override that method. So when I will execute this command, we will get the same output as we were getting earlier. But as you can see, it has given me an error at circumference. And what is the error? The error says that the method circumference is undefined for the type shape. Why it is undefined for the type shape? Because we are passing the reference of the shape class and there is no method in the shape class with the name of circumference and 2 arguments. So it will not execute this command. That's why it has given me error. So let's delete it out. And when you will execute the command, you will get your desired output again. And you can achieve one more important thing using upcasting of object, and that is you can call any of the shape class function using your object of the rectangle class. Until or unless it is not overridden, you can still call the functions. So that will be all about the hierarchical inheritance. In this tutorial, we will learn about static keyword. Static keyword can be used with a variable name, a method name, a class name, or a block of code. So let's see what does that mean and how can we use it. So if you want a member function or a data member to be common to all objects and that can be accessed without using a particular object, that is our static member. So that means whenever you create a static variable or static method, it will belong to the class and not to the object. All the object of that class will refer to the single copy of that static variable or static method. Our static variable or static method are basically stored in a separate memory. So whenever you create a program and assign your variable or method to be static, it will then be loaded in a separate memory called the context memory. Now our another important point is that any member function or a variable that is declared as static should be called using a class name and not using an object name. Yes, it's true. You don't have to create an object to call the static variable or static method. It can be called using a class name. Basically, it is a protocol to use that because static variable can be used to refer to the common property of all objects. For example, suppose you are creating a program to store the name of 100 students. So those 100 students must belong to a school, and then you have to display the name, roll number and school of that student. So now you have to create 100 instances of that class to display the data of 100 students, and you will be displaying the name of your school in each and every instance. That means you will be using the memory location for the variable school name in each and every instance. So it is a kind of misuse for the memory location. So to eliminate this kind of problems, we have used static variable. By declaring a variable or a method to be static, it will just allow a single copy to be created, and whenever you create an instance of a class, it will refer to that copy only. So let's create a program and see it practically, and then I will tell you why main method is static. So go to Eclipse, create a program. See, I have created a simple program right now. In this, I have just taken an integer variable as count, and then I have created a method called increment, and in between that I have incremented the variable and then printed the line. So this is a simple program. Right now we are not using any static keyword. So now let's just create the objects and see the output first. Create 2 or 3 objects. See, I have created 3 objects, and then I have called the increment function once with each and every object. So let's execute the command and see the output first. As you can see in the console window, we are getting 1 as an output each and every time because int count here is our instance variable. I have told you about the instance variable in the class and object tutorial, so you can refer to that. Here I will tell you one thing. So instance variable is something which is created with the creation of an object. That is, whenever you instantiate a class, you create an object, a new instance of that class is created. So whenever you create an object, a new copy of that class will be created. That means our count will be initialized to 0 each and every time for each and every object. So that is the reason why we are getting 1 as output each and every time. What will happen if I will make this static? So by definition, that means now we will be having a single copy of that variable for any number of instances. So let's execute the command and see the output. In the console window you can see I am getting the different output, that is 1, 2 and 3. So as you can see, it doesn't matter how many instances I create, a single copy of count variable was stored. So when I created the first instance, we have got the count value as 0. Now, it doesn't matter how many times you create the object, it will maintain the single copy for the integer count. So, when I call the first function, that is c1.increment, using the first object, it will increment the value of count by 1 and print it out. Now, as you know, we have the single copy for the count, so our integer value count will have the value of 1. When I call the increment function again using the other object, it will again increment the value from 1 to 2 and so on. You can go on with any number of instances you create, you will get the incremented output each and every time. Similarly, you can create a method to be static. Let's create a decrement method and make it static. See, I have created the decrement method and made it static. Let's print it out and see the output. See, we have got the output as 210 because when I incremented the value, that is when I called the increment function with the third object, the value of count was 3. So when I started decrementing, it will go from 2 to 0. But see, I am getting a warning at all the 3 statements. That is, the static method decrement from the type counter should be accessed in a static way. That is, it is not the preferred way of using the static member function. So what I have to do is, I have to use it with the class name. So our class name is counter dot decrement function. So this is the way to use the static member function. Now let's execute the command and see, you have got the desired output and we are not getting any warning. So it doesn't matter how many times you call it, it will work the same way. Let's execute again. You can see we have got the same output. Now let's move on to another important point. That is, now create a simple variable called it string name. So now, as you can see, I have 2 variables. The first one is static variable and the another one is non-static variable. Similarly, I have 2 methods. The first one is the non-static method and the second one is the static method. So, as you can see, I can use the static member in a non-static method. But can the vice versa be true? I have used a non-static member in the static member function. See, it has given me an error. The error says that cannot make a static reference to the non-static field name. That means I can't use a non-static member in a static member function. So you have to remember that there is one more limitation in using static keyword is that they cannot refer to this or super keyword. We will learn about the this and super keyword in our upcoming classes, but you have to remember that it cannot refer to a this or super keyword. So now let's move on to our last important topic of this tutorial, that why main method is static. As we all know that main method is the start of the execution of any program. So whenever you compile your program, JVM looks for the main method to start the execution. So the first important point is main is a method and it is the start of execution of any program. So as we have learned about static keyword is that using a function name with a static keyword will not need an object to call a function. So being our main method to be static, JVM, that is our Java virtual machine, can call it without creating an object. So whenever you compile your program, JVM will look for the main method first. Now suppose you are creating a program with tens or hundreds of classes. All the programs will have some constructors. There must be a constructor overloading in that also. So what will happen if there is no main method to call or to start the execution from a single entry point? Then how JVM will decide which classes constructor to call first or which overloaded constructor to call first? So that's why there is a need of main method, and main method has to be static, because if it is not static or in a particular format, we will get an ambiguity error. And why is that? Because we all know that main is a function and it can be overloaded. So to remove that ambiguity error, we use the proper syntax of main as public static void main, and in between that string array of arguments. Now you might be wondering that we are using the main method to start the execution of a program, but we are not using a class name to call that main method. I know you are not thinking, but I am letting you know because this is too an important point. If you remember from the first tutorial, I have told you that suppose you are creating a program. So in that program there will be a number of classes. and in between those classes there will be a class which will contain your main method. So the file name of your that program should be same as that of your class name which contains the main method, and that is how your JVM finds the main method to start the execution of any program. If you save the program with a different name, then whenever you compile your program, it will give you a runtime error that JVM doesn't find your main method. So it is a compulsion in Java that whichever class contains the main method, the class name of that program should be same as that of your file name. So this will be all about the static keyword and why main method is static. In this tutorial, we will learn about access modifiers, or what we call as access specifiers. Till now, what we have studied was that we can access any data of any program, either it is variable or a method, to any other program. But there is a way by which we can restrict the use of data, that is our variable or method, depending upon the security of our program, and that can be achieved by using the access modifiers. Java has different number of access modifiers depending upon the access level of the class, method, variable or constructors. There are basically 4 types. First of all, we will look for the access modifier with the example of variables and methods only. And then at the end of the session, I will tell you how to use access specifier with the class. So the first one is private. It means the most secured one. So those variables or methods which are declared as private can only be accessed within the class only. It helps in encapsulation. Outside the class, they cannot be accessed. It will give you a compile time error. Our second type is protected. Those variables or methods which are declared as protected can only be accessed by the subclasses of that package or any other package. Suppose you have created a program in that you have declared a variable as protected and a method as protected. So those protected methods or variable can only be accessed by the inherited classes of that package or any other package. But remember that the class has to be inherited to use the protected members. Our next type is the public one. Using public modifier, you can access your data from anywhere. The last one is the default, which is also known as friendly. That can be accessed within the package only. The security level of default comes between the protected and private. So now let's create the program and see the example for each and every one of them. So go to Eclipse, create a file. I have created a class named private modifier. So let's create a different class. I have created a class named private. Let's declare some variable and method. See, I have created a method display to just print a line, and then I have declared and initialized a variable. So to make it private, what you need to do is write private before data type, and same for the method, you have to write private before the void. That will be all. You have made your variable and the method as private. So let's try to create an object first. Our class name is private, p, new, private. We have created the instance of a class. Now let's print the value of a. And now let's call the display function. See, I have tried calling both of them, the variable and the display function, but I am getting the error at both the lines. The error is the method display from the type private is not visible. And then we have the same error at line number 19 for our variable, that the field private is not visible. So from this you can conclude that we can't access the private data of any class in any other class. There is one more important thing. Suppose I am creating a constructor. This is my class name. I have created the constructor. Let's print a statement. So I have given a statement that if I become private, then I will not let you make a object either. So till now, as you can see, we were able to create an object. But if we declare our constructor as private, we will not even be able to create an object. See, we have got an error again. The constructor private is not visible. So as you can see, making a variable or a method private, you will not be able to use that method or variable in any other classes. Similarly, if you make a private constructor, then you will not be able to create an object either. So this will be all about the private access specifier. But I will tell you one important thing, and you have to find me the answer. And the question is that even if it is private, there is still a way to get access to those methods and variables which are even declared private. You have to find me the answer. If you will find any difficulty finding the answer, I will tell you later on in the comments, but still you have to find me the answer. So now let's move on with the another type, that is the protected. So to understand this, let's create two sample packages. The first one is sample1. So let's create a file in the sample1. See, we have created a simple program in sample1 package by the name of example1, and in between that we have created a simple display method. Let's make it protected. Now we have got a protected method over here in example1 class. Now let's go to sample2 package and create a class over there. See, we have created an example2 class in the sample2 package. So now, as I have told you, protected member in a superclass can only be accessed by the subclass if we inherit that class. So let's inherit the class. As I have to inherit the class from the sample1, I have to import that package. So let's import the package first. See, we have imported our package. Now let's inherit this class with example1. So write the extends keyword and the file name example1. See, we have inherited example2 class from the example1. So what we have done till now is we have created a package sample1, and in that we have created a class example1 that is public. It is public because it can be accessed from any of the class or from any of the package. And in between that I have created a method that is protected. And then we have created another package in the example2 class. So now let's create an object and see if we are able to access the protected method of example1 class or not. So as you can see, I have created an object e2 for the example2 class, and then I have called the function display2 from the sample1 package example1 class and display3 from the sample2 package and example2 class. So now let's execute the command. As you can see, I am getting both the outputs. So from this you can conclude that protected member in a class can be accessed only by the subclasses in other packages or any class within the package. Suppose if I forgot to write the import, it will give me an error that example1 cannot be resolved to a type. So to resolve it to a type, that means to tell the compiler that it is a class, we have to import our package. You can also make this method as protected by writing this. It will work the same way. So this will be all about the protected modifiers. And remember one thing, while you are creating a protected modifier, so you have to make it public so that the protected members can be visible to other packages. So this will be all for the protected. Now let's have a look at the public access specifiers. So for public access modifier, we can use the same example. To use the public access specifier, what you need to do is you have to write public in place of protected, and that will be all. You can either use it from one package to another package, or you can use it within the package or the class. That will be all. It will work the same way and it will display you the same result. So these are the basic access specifier which we will be using in our programs. The last one is the default type. We can understand that too with the same example. What you need to do is you have to remove the public keyword from here and then the public keyword from here. Now as you can see, this program looks similar to that which we were studying till now. So now let's go to example 2. Now remove this public too. Now everything is by default. That means we have not used any type of access specifiers to provide special security to any method or variable, or to provide any special permission to any method or variable. So by definition, default access specifier says that if we are declaring any method or variable as default, then we can't access it in any other package. So as I am trying to access the example 1, that is from the sample 1 package, in our another example 2, which is from the sample 2 package, but it is giving me an error that we can't use it because it is not visible to that package. We have created another program in the same sample package. Now if we inherit example 1 class over here like this, and then we will create the object and call the function of the example 1 class, then it will not give me an error, because being a default access modifier, we can use the default variable and method in the same package. So if we will execute this program, we will get our desired output. So that will be all for all the access specifiers. Now let's summarize all of these and see the chart of the access specifier. We have the 4 access modifiers, that is private, default, protected and public. Y means yes, N means no. So private can be accessed within the class, yes. Within the package, no. Outside the package, no. Outside the package by subclass, no. The third option, outside package but by subclasses only, that means inheritance. So by using default access modifier, we can access our variable and methods within the package and within the class. We have seen the example for that. The third one is the protected. It can be accessed within the package, within the class and outside the package using the subclasses, that is inheritance. But it can't be accessed outside the package without using inheritance. The last one is the public. It can be accessed from anywhere, within any class or within any method. And remember one thing, as I have told you, I will tell you about how to use access specifier with the class. A class can have 2 access specifiers. The first one is the default, which we have seen. If we will not write anything before a class, it will be by default. And the second one is the public, which we already have seen in the protected type. So this will be all regarding the access modifier and access specifiers. If you will have any doubt, you can ask me in the comment section. That will be all for this lecture. In our next tutorial, we will learn about. Thank you.